Good morning all. I am Padma. I'd like to discuss on ultrasound imaging. Here the ultrasound imaging is similar to the sound signals how it been traveled in the air. Similarly, the ultrasonic images also propagate in the medium. So when the signal is been traveling, the signals above 20 kilohertz are used for ultrasound imaging, where these signals travel in forms of compression and refractions, and these signals has traveled to the human body, and it gets some of the information is get transmitted and some will get reflected. So that is how the signal is getting transmitted, and this is how the for various tissues in the fat or in the liver, kidney or brain or in the blood, this is how the propagation velocity of the signal that travels in the human body. So similar to the normal sound signals, and this is how C is equal to lambda V is the expression where the signal gets traveled with certain velocity. So this so here it shows physically how the incident ray is being transmitted onto the tissue, and some of the information is getting reflected, and some of the signal is getting reflected, and some of the information is getting transmitted into the body. So that is how the signal, when it is getting incidented and reaches to the target area and gets reflected back, there is a time taken for the information to travel. So this is what gives the information about how the signal is getting transmitted from one medium to another medium. So when it is traveling from one medium to another medium, there is a difference in the velocity of the signal that it travels. So that is how the signal is getting reached to the target area and again getting reflected back. So this is how there is the transducer. The transducer is connected with the BNC connector to the instrument, and it has a piezoelectric quartz crystal which has a transmitter and the receiver. Both are being built in onto the same transducer. So the transmitter and the receiver are both are placed at the same parts of the transducer end. So this is the schematic which is being required. This is the human body, from where the human body, the electrode or the transducer is being just placed onto the region which we need to take an image, an ultrasound image. So this transducer, the signal is getting traveled and propagated to the target area, and again it gets reflected back. There is a time delay. So this delay tells that how much is the information getting reflected. So that is how the signal, there is a pulse generator. So the time taken for the transmission of the signal and the received signal, there should be some delay between a transmitter and the receiver. The distance between these two tells the information how it is being reaching and acquired by the system. So after picking up the signal, there is a imaging and storage. The computer processing information is being required for the images data storage as well as the display, and we can even do the processing where the correct information can be achieved. So there are different types. One is an E-scan. E-mode. E-mode is a general common mode for the image processing. That is, the amplitude of the information of the recorded echo from the tissue is being recorded with respect to the time. In this mode, we get mainly the acoustic impedance between the two boundaries can be identified, and the distance between the measured of the tissue structure and the interfaces can be also been computed. Next is the B mode scan. So there are three types. One is an A mode, B mode and M mode, where B mode represents the brightness of the information of the signal that is being received, which shows the strength of the echo from the tissue structure, which is also a two-dimensional image where the tissue structure and the transducer point we can able to identify on the information on the display. So here we can see the similarities, the physical structure, how the heart is, with various valves and opening and the closure of the valves, and similar to the ultrasound image, where the left ventricle, right ventricle, and there are the four chambers and the valves in between. and the signal transmission can easily be observed and compared with the help of the ultrasound imaging.